Kia ora Year 9. This is the second video from the harder HCF and LCM worksheet, and this time I'm going to do row 2, which is this one here, so it's questions B1 to B4. Now in all of these we start using the Venn diagram method to find the highest common factor and the lowest common multiple. There are other ways to do this, and some of you might prefer to do it by hand, but I find the Venn diagram method pretty good. So we're going to start by figuring out the highest common factor of 90 and 52. So the kind of slow and clunky way to do this is to list all of those factors out, right? So we're not talking about prime factors now, we're talking about ordinary factors. So we could go 1 and 90, 2 and 45, and so on. But it gets a bit tedious, especially when we start getting bigger numbers. So if we use our factor tree approach, we're basically going to see which factors, which prime factors are in common, and then we're going to combine them. So it goes like this. And most of you watching have got this pretty firmly in class, but just in case. So 90 we can split up as usual. I'll do 3 times 30, and then 3 times 10, and I get 2 times 5. 252, well, it really doesn't matter what you pick, so I'll just pick 2 times 126. Now 3 goes into 126. I know that because we talked about our weed divisibility tests, and we can add those numbers up quickly and get 1 plus 2 plus 6 is 9. So we know that 3 is a factor. So it's 3 times 42, and that leaves me with 6 here and 7 here. Now I've stopped doing the circle tick thing because by this stage you've got pretty good, I think, at spotting when you've got to a prime number. We can write those numbers out like this. So 90 is equal to 2 times 3 times 3 times 5. I don't have to go in that order, but it keeps my working systematic if I do. So it's a good habit to get into. And 252 is 2 times 2 times 3 times 3 times 7. Now usually if we were stopping here, we'd put those into index form, right? And we'd go 2 times 3 squared times 5, and we'd go 2 squared times 3 squared times 7. And we can still do that, that looks nice, but for working with the Venn diagrams, it's actually better to stop at this point and start chucking things in to the Venn diagram. So in this one, we're going to have the factors of 90, and in this one, I'm going to have the factors of 252. I don't know why I drew that bigger, it doesn't matter. The main practical thing when you're doing this in your book is to make sure that you leave a nice big area in here for your overlap, because sometimes we end up with a lot of numbers in there. So we look at which ones are in common and we tick them off as we go. Well, we've got 2 here and we've got a 2 here. We've got a 3 here and a 3 here. And we've got another 3 here and another 3 here. So the factors in common, the prime factors in common, I should say, are 2, 3, and 3. That's going to be my highest common factor. Now I just have to place the other ones. So I've got 5 as a prime factor of 90, but not 252. And here I've got 2 and 7. So let's just make sure we can see what's going on. So the 5 is sitting out on its own, and so are the 2 and the 7. So I can now very quickly find the highest common factor. The highest common factor is 2 times 3 times 3, which is 6 3s, or 9 2s, which is 18. Now the LCM, well, you might be thinking, well, this is a bit of a pain. I have to multiply all these numbers together. But there are some smart ways to go. We know that all of these ones times together are going to give me 90, because that's the whole point. They're the prime factors of 90. So it's going to be 90 times these leftover ones that are prime factors of 252 only. So it's going to be 90 times 14, right? 90 times 2 times 7. And we can do that in our heads. We can work out that that's, well, we get 1260. So let's think about a smart way to do that in our heads. Using number strategies from primary, I'm doing that as 900 plus 4 9s are 36. So 4 90s are 360. So you can use one of those. Okay, so that's your highest common factor of that one and your LCM of that one. Let's look at the next question. Right, easier numbers this time, so it's going to be even faster. The lowest common multiple of 24 and 42. I'll do this using the Venn diagram. This is one where you might want to just do it by hand, because you'll find the numbers fall out pretty easily. So 24 is 4 times 6. And over here I've got 42, which is 7 6s. Draw your diagram and put in your intersection. So what have I got? Well, I've got a 2 and a 3 here, and a 2 and a 3 here. So they are going to go in the intersection of the two things. I should also label my diagram beautifully, or I wouldn't be a proper maths teacher. 2 3s, and here I've got a 2 and I've got a 2. So they sit out here, and over here I've got a 7. So very quickly we can see that the highest common factor is going to be 2 times 3, which is 6. And what about the LCM? Well, the LCM is 2 times 2 times 2 times 3 times 7. But remember, I don't need to do it that slow way, because I can just say, well, we know that all of those times together are 42. So the LCM is going to be, here's my proper pen, 4 times 42. Right, so I'm timesing in those two to the 42, and that gives me double and double, 168 for the lowest common multiple. So that's 2 of them done. Next one's got some bigger numbers. I'll scoot back to the top so we can see what they are. Right, highest common factor and lowest common multiple of these two, 168 and 180. So what I suggest you do, now that you've got used to these videos, is that when I start doing a question, if you're going to actively be learning while you're watching, you're going to want to have a pen and paper with you. So I want you to pause the video, see if you can do it on your own, and then you don't have to listen to the whole video. But you do have to make sure that you're really understanding. But it's over to you. So we've got 2 here, and 84, 7 12s, 3 4s for the 12, and off we go. We've got 2 2. So 168 is equal to 2 times 2 times 2 times 3 times 7. Now let's do 180. 30 times 6. I've got 5 times 6 here, 2 times 3 here, and 2 times 3 here. So 180 is 2 times 2 times 3 times 3 times 5. And it's time to put them in to the Venn diagram. Doesn't matter which way around you go, but we'll do 168 here and 180 here. Right, so I'm looking for the common factors, and I'm systematically going to tick them off as I find them. Right, because it's very easy, and especially when maths gets a bit harder, to make a little mistake because you were not working with a thorough method. Okay, so we've got 2 and the 2, and then we've got a 3 and a 3. So just check, is the 2 sitting over here? No, it's not. Is the 7? No, it's not. So neither are those. So we plonk them on the diagram. In the intersection we'll have 2, 2 and 3. And in the 168 circle we'll have 2 and 7. Over in the 180 we'll have 3 and 5. So the highest common factor is 2 times 2 times 3, which gives me 12. And the LCM is going to be, right, now what's going to be easiest here? Well, I think I'm going to do, it's all of these numbers times together are going to give me 168. Right, so that's 168 times 15. Now, what's that equal to? Well, I'm doing this in my head, so it's going to be 1,680 plus half of that, so 840, which is 2,520. So that's one where it really does make sense to use this method, because it probably would have taken you a while to get there by skip counting in 168s. Now the last question is really cool because it has 3 that we have to work with. So we have to think, how can we extend our idea to work with finding the HCF and the LCM for 3 numbers? Right, so have a think about how you do that, and before you watch me do it, I want you to try this one on your own. Okay, so hopefully you came up with the idea that we'll do 3 factor trees again. I'm going to pause the video and do those now. Right, so we've got the factor trees done, and we're now going to figure out what we do to find the HCF and the LCM of 3 numbers. So before I just had 2 circles, now we're going to have 3. And we're going to look at this, and we want to make sure that we've got room in the intersection of all 3 to draw them. So we've got 72 here, we've got 180 here, we've got 540 here. So which factors are in common to all 3? Well, we've got a 2 here, go really slowly, 2 here, 2, 2, 2, so that's good. Have I got another 2? Yes, I've got another 2, 2, 2 and 2, and then I've got another 3, 3, 3, and 3. I haven't got another 2, so that one's just going to sit there. But I have got another 3. So there's a 3 in here, and a 3 in here, and a 3 in here. So we have to squeeze somehow all of those numbers into that intersection. So let's see, we've got 2, 2, 3, and 3. Draw your diagram more beautifully than me, please. It's a dog's breakfast. If that were in your book, I would be a bit sad and grumpy. Right, so the 72, I've got a 2 here. This is the 180, and I've got a 5 here. The reason I'm going slowly is because we want to figure out where exactly in that diagram we're going to plonk these other numbers. For the 540, I've got a 3 and a 5. So the only place the 2 is turning up is in the 72 circle, so we can put that in here. And the only place the 3 is appearing is as a prime factor of 540, so that can go down here. But look at this 5. The 5 is in common to the 540 and the 180. So we want to put that in here. And that would let me answer a whole lot of other questions about pairs of those variables. But in this case, all we were asked for is the HCF of the 3 numbers. So the HCF of the 3 numbers is going to be the bit in the intersection of all 3 circles, which is 4, 9, so that gives me 36. Now, what about the LCM? Well, the LCM is going to be all of them times together. So it's going to be the intersection, 2 times 2 times 3 times 3, times 2 for this one here, times 5 times 3. So that gives me 36 from those ones, times 2 5s are 10, times 3. So that's 360 times 3. I'm doing this in my head, so that's why I'm writing all of these calculations down. So 36, 72, 108 times 10 gives me 1080. And we can check that. If we think about skip counting in 540s, it would go like this, 540 and then 1080. So we can see that 540 is a factor here. Now let's see if we skip count in 180s. Do we get to 1080? Well, yes we do, because 18, let's see, 18 times what gives me 1080? Well, 18 5s are going to give me 90, 18 6s will give me 108, 18 60s will give me 1080, so that's going to work. And lastly, you can do the same thing with 72. So 72, 144, and if we kept going, eventually we'd get to 1080, because 15 times 72 is 1080. Okay, so there you go. Very long video, but hopefully you've really got the hang of that method now. I'll do some of the harder ones later on today if anyone watches this one. Thanks for watching.